We'll talk in more detail shortly about internals of parallel streams, really learn how it works under the hood and what things you can change and what things you can't change. But before we get to that, I want to kind of return to our simple example that we did earlier of the SearchStream program and show you how to implement the SearchWithParallelStreams class. And this will sort of be a recap, but it's kind of cool. Even though it's a recap, it'll give us a chance to learn more about how parallel streams work. So if you recall, this particular example is the one that took the sequential stream, the search with sequential streams that we talked about a couple weeks ago, which only used one thread of control and therefore took about 2,000 milliseconds to run. And it makes one tiny little change, changing something to parallel stream instead of stream, and voila, we get basically a super linear speed up in terms of the number of cores. And I'll talk more later about why we get a super linear speed up here. It's kind of cool. We're going to focus on the same two methods as we did before, process stream and process input, except now this is in a different class, the search with parallel streams class. This is what things look like. That looks very similar to before, intentionally. And we look at the intermediate and terminal operations map, filter, and collect. So the way this works is the process stream method for this variant is going to use a parallel stream to search a list of input strings, where each string is a different work of Shakespeare. So that's similar to before. Actually, it's identical to before. So you got Hamlet, Macbeth, Julius Caesar, and whatnot. And under the hood, it's going to use the common fork join pool of worker threads in order to do the parallel processing. So we'll look at that in more detail shortly. And it returns a list of lists of search results. So that's also the same as we had done before. The process input method, which as you can see is called here during the map phase in process stream, that essentially uses another parallel stream. So we've got two parallel streams to search each input string to locate all occurrences of the list of phrases, if there are any occurrences, in that particular input string. It also uses the common pool of worker threads. So the thing to remember here is that, and we'll talk a lot more about this later, but these two parallel streams each use the common fork join pool, and every parallel stream in a given process uses the same common fork join pool. And that is actually by design, and I'll talk about why they do it that way. And it might be interesting to kind of think through your head, why do they do it that way? Why do they put everybody in the same pool? And there's actually a good reason. And this will return a list of search results. So each call to process input returns a list of search results, and then those things are all consolidated by process stream into a list of lists of search results. And then that'll be passed off to print phrases, as we talked about before, and that code is actually the same. So that's just a quick overview, just refreshing your memory about how this particular example is defined. Hopefully no real surprises there. It looks almost identical to what we had before, just with stream replaced the parallel stream for the factory method to make the stream.